Hi everyone. Today we're going to study the hyperbola with center at HK. The hyperbola with center at HK has this general equation, that is ax squared plus cy squared plus dx plus ey plus f equals 0, where a and c, these are the coefficients of x squared and y squared respectively, are in opposite sign. Every hyperbola with horizontal or vertical transverse axis has an equation of this form. The general equation can be transformed into its standard form. The standard equation of hyperbola with center at HK and transverse axis parallel to x-axis is here. The square of x minus h over a squared minus the square of y minus k over b squared equals 1. Take note that the x variable is positive and y is negative. The standard equation of hyperbola with center at HK and transverse axis parallel to y-axis is here. That is the square of y minus k over a squared minus the square of x minus h over b squared equals 1. Take note, the y variable is positive and x is negative. Every hyperbola has a pair of intersecting lines as asymptotes. The equations of asymptotes are here. This is y minus k equals plus or minus b over a times the quantity x minus h. This equation is for hyperbola with transverse axis parallel to x-axis, while the equation y minus k equals plus or minus a over b times the quantity x minus h is for hyperbola with transverse axis parallel to y-axis. Let us see this example. Discuss and sketch the graph of the hyperbola 4x squared minus 9y squared minus 16x minus 18y minus 29 equals 0. We can see here that the equation is in general form. For our solution, let us convert the equation into standard form. We will copy again this equation, but we must transpose the constant to right side. Now, the negative 29 is on the right and becomes positive 29. Next is, we are going to group the x and y variables respectively. So the first two terms here now are the x variables, while the last two terms of the left side are for y variables. Let us put them inside a grouping symbol. And from here, let us factor out the common factor, respectively. For the x group, the common is 4, so we factor it out. And for the y group, we factor out the negative 9. The next step here is to complete the square. Let us find the missing constant to complete the trinomial here for the x and for the y respectively. It means we're going to add a value that is equal to 1/2 of b and must be squared. The b here is the coefficient of x. So the number 4 comes when we take half of -4, it becomes -2, and the square of that is +4. While the number 1 here comes from the coefficient of y, which is 2, we take half of that, it becomes 1, and when we square it, the number 1 is the result. Now, look at the right side. We have here plus 16. This comes from this number 4 that is multiplied by the factor outside. 4 times 4 is 16. Actually, we add a number 16 here. That is why we add also a constant 16 on the right side. The same is true with this -9. We see here a +1 that when we multiply this to -9, the answer is -9. We are adding a -9 value to the left side, and that same value must be added to the right side. And the next step now is to factor out this perfect trinomial, and it will lead to the square of a binomial. The x squared minus 4x plus 4 becomes the square of x minus 2, while y squared plus 2y plus 1 becomes the square of y plus 1. And the right side we simply combine together. We have now equals 36. And from here, let us make the right side equal to 1. Let us divide this equation by 36. So we have now the square of x minus 2 over 9 minus the square of y plus 1 over 4 equals 1. And from here, we can say now that the general equation is transformed into standard form. We can say also that this is a hyperbola with transverse axis parallel to x-axis, because the x variable here is positive and the y variable is negative. From this standard form, we can take now the center. We can see here the x minus 2, so the h is equal to +2. The y plus 1 is here, so we can take the value of k as -1. So the center is the point 2, -1. Next are the vertices. We can take now a square, which is the denominator of the variable x, that is 9. Getting the value of a, let us take the square root of this equation. So a equals 3. It means to say the vertices are 3 units to the right or left of the center. So the coordinates of the vertices are 5, -1, and -1, -1 respectively. Let's have the endpoints of conjugate axis. We can take the b square, that is the denominator of the y variable. This is equal to 4. Getting the square root of this equation, the value of b equals 2. It means the endpoints of conjugate axis is 2 units above or below the center. It means the coordinates of the endpoints are 2, 1 and 2, -3. Next are the foci. Let us compute for C using this formula, plus or minus the square root of a square plus b square. The a square is 9 and b square is 4. So we take the sum of 9 and 4. So we have plus or minus the square root of 13. Simplifying this value, we have the plus or minus 3.6. We say that the foci are 3.6 units to the left or right of the center. It means the coordinates of the foci are 5.6, negative 1 and negative 1.6, negative 1. Let us use now the GeoGebra to plot the hyperbola. The pair of graphs here is the hyperbola. The center at 2, negative 1. The vertices are here respectively. The endpoints of conjugate axis are here. And the foci are here and here. Let us get the value of eccentricity. The formula is E equals C over A. Let us substitute the corresponding values. The value of C is 3.6 over A, which is 3. And this is equal to 1.2. Next is the length of latus rectum. The formula is 2b squared over A. Substituting the values, we have 2 times 2 squared over 3. When we simplify this, the value is 2.67. We know that the latus rectum passes through the respective foci. So here are the 2 latera recta. Next are the asymptotes. Since the transverse axis is parallel to x-axis, we're going to use this formula. Y minus k equals plus or minus b over a times the quantity x minus h. This y minus k, we will use the value y plus 1. For the x minus h, we will use the value x minus 2. And for the b over a, we will substitute the corresponding values as 2 over 3. So this is now the equations of the asymptotes. Let us simplify this equation so that we can have the specific equation for respective asymptote. Let us cross multiply this number 3 to the left side. So we have 3 times y plus 1 equals plus or minus the number 2 remains as factor to x minus 2. Let us now distribute number 3 to y plus 1. Also distribute these 2 to x and negative 2. So we have now this 3y plus 3 equals plus or minus 2x minus 4. Let us transpose this positive 3 to the right side. So we have now 3y equals negative 3 plus or minus 2x minus 4. Let us now segregate the plus or minus so that we will have the specific equations for the asymptotes. For asymptote 1, we will use the plus sign. For the second asymptote, we will use the negative sign. Let us remove the respective grouping symbol and combine the constants. So we have here 3y equals 2x minus 7. For the second asymptote, we have 3y equals negative 2x plus 1. Finally, the equations for the asymptotes are y equals 1/3 times 2x minus 7, and the second asymptote is y equals negative 1/3 times 2x minus 1. The next step is to draw the asymptotes. First, let us draw the rectangle whose sides are parallel to the coordinate axis and passing through the vertices and the endpoints of the conjugate axis. Here is the rectangle, and the asymptotes are the extension of the diagonals of this rectangle. So here are the respective asymptotes. This is our final answer. I hope you learned something from this video. See you again next time.